To address the issue of lead leaching from plumbing due to electrical grounding, particularly in older homes with lead pipes or lead solder, consider these steps to petition for a change in the electrical code. Firstly, gather comprehensive data and evidence. Document specific instances of lead leaching from plumbing systems that are directly linked to electrical grounding practices. Collect relevant research studies and scientific reports that support the connection between electrical grounding and lead contamination in water supplies. This empirical evidence will form the foundation of your petition and demonstrate the validity of your concern. Secondly, form a strong coalition. Reach out to other water utilities facing similar challenges, public health agencies concerned with water quality, and environmental organizations dedicated to protecting water resources. Building a broad coalition will amplify your voice and demonstrate widespread support for the proposed code change. Seek input from coalition members in developing the petition, ensuring it represents a diverse range of perspectives and expertise. Thirdly, identify the relevant authority responsible for the electrical code in your jurisdiction. This could be the National Electrical Code, commonly referred to as NEC, which is widely adopted across the United States, or it could be state or local building codes that govern electrical installations within your specific region. Understanding the specific authority is crucial for directing your petition to the appropriate decision makers. Fourthly, prepare a detailed and well-structured petition. Clearly outline the problem of lead contamination caused by electrical grounding, providing specific examples and quantifiable data to illustrate the severity of the issue. Present the supporting data and evidence you have gathered, including research findings, case studies, and expert opinions. Propose a specific change to the electrical code that directly addresses the issue of lead leaching. This could involve modifying grounding requirements, mandating the use of alternative grounding methods, or implementing stricter inspection protocols. Explain the benefits of the proposed code change, emphasizing the protection of public health and potential cost savings associated with preventing lead contamination. Fifthly, submit the petition to the relevant authority, ensuring it is accompanied by all supporting documentation, including data, research reports, and letters of support from coalition members. Clearly state a reasonable deadline for a response from the authority and request a public hearing to discuss the issue in detail. This will provide an opportunity to present your case, answer questions, and engage in constructive dialogue with code officials. Sixthly, actively advocate for your petition and be prepared to testify at public hearings. Present the evidence and arguments supporting the proposed code change in a clear, concise, and persuasive manner. Address any objections or concerns raised by opposing parties, providing factual information and expert testimony to counter their arguments. Emphasize the importance of protecting public health and the potential consequences of inaction. Seventhly, build public support for your cause. Engage with local media outlets, including newspapers, television stations, and radio stations, to raise awareness about the issue of lead contamination and the need for code changes. Partner with community groups and organizations to disseminate information and mobilize public support. Gather public support through petitions, letters to elected officials, and social media campaigns demonstrating widespread concern and demand for action. Eighthly, be prepared to negotiate and compromise with the code authority. The code change process often involves finding common ground and reaching mutually agreeable solutions. Explore alternative solutions that address the safety concerns related to electrical grounding without compromising public health or imposing unreasonable burdens on homeowners or contractors. Flexibility and a willingness to compromise can increase the likelihood of a successful outcome. Ninthly, monitor the implementation of the code change once it is approved. Track the progress of the code change through public hearings, revisions, and adoption by relevant jurisdictions. Ensure that the new code is implemented effectively to prevent future lead contamination. This may involve providing training and education to electricians, plumbers, and building inspectors, as well as conducting regular inspections to ensure compliance. In addition to these steps, consider seeking legal counsel if necessary to ensure that your petition meets all legal requirements and that your rights are protected throughout the process. Collaborate with other stakeholders, such as plumbers and electricians, to gain their support and address any concerns they may have. Their expertise and experience can be invaluable in developing effective and practical code changes. Be persistent and advocate tirelessly for the protection of public health. Changing electrical codes can be a complex and time-consuming process, but your efforts can make a significant difference in safeguarding the health of your community. Lead contamination poses serious health risks, particularly to children, and preventing it through proactive code changes is a worthwhile endeavor. By following these steps and engaging in collaborative advocacy, you can increase the likelihood of achieving meaningful and lasting improvements to electrical codes that protect public health and prevent lead leaching from plumbing systems. Consider that the National Electrical Code, or NEC, is a comprehensive set of standards that governs electrical installations in the United States. It is developed and updated every 3 years by the National Fire Protection Association, also called NFPA. The NEC aims to ensure the safe and reliable use of electricity by providing detailed requirements for wiring, grounding, overcurrent protection, and other electrical system components. The code is widely adopted by state and local jurisdictions, and compliance with the NEC is often required by law. When addressing electrical grounding in the context of plumbing systems, it is essential to understand the relevant sections of the NEC that pertain to grounding and bonding. Grounding refers to the intentional connection of electrical circuits and equipment to the earth, providing a lower impedance path for fault currents to flow back to the source. This helps to prevent electrical shock hazards and ensures that overcurrent protection devices, such as circuit breakers or fuses, will operate properly in the event of a fault. Bonding, on the other hand, involves connecting metallic parts of electrical and plumbing systems together to create an electrically continuous path. This helps to minimize voltage differences and prevent stray currents from flowing through the plumbing system, which can contribute to corrosion and lead leaching. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding jumpers to ensure that electrical systems are properly grounded and bonded. It also addresses the specific requirements for grounding and bonding metal water piping systems, which are often used as grounding electrodes. According to the NEC, metal water piping systems can be used as grounding electrodes if they meet certain requirements. The piping system must be electrically continuous and must be connected to the grounding electrode system with the grounding electrode conductor. The connection must be made within 5 feet of the point where the water service enters the building. The NEC also requires that metal water piping systems be bonded to the electrical service equipment enclosure and to any other metal enclosures that are likely to become energized. This bonding helps to minimize voltage differences and prevent stray currents from flowing through the piping system. However, the use of metal water piping systems as grounding electrodes has been a subject of debate due to concerns about corrosion and lead leaching. When electrical currents flow through metal water pipes, they can cause corrosion of the pipe material, particularly in older homes with lead pipes or lead solder. This corrosion can release lead into the water supply, posing a health risk to consumers. To address these concerns, some jurisdictions have modified the NEC or adopted additional regulations to restrict the use of metal water piping systems as grounding electrodes. Alternative grounding methods such as ground rods or ground plates may be required in certain situations. The NEC also includes provisions for isolating metal water piping systems from electrical currents to minimize corrosion. This can be achieved by using dielectric unions or non-conductive couplings to interrupt the electrical continuity of the piping system. In addition to the NEC, other codes and standards may also be relevant to the issue of lead leaching from plumbing systems due to electrical grounding. The Uniform Plumbing Code, or URC, provides requirements for plumbing installations, including the materials and methods used for water piping systems. The Safe Drinking Water Act, or SDWA, establishes standards for drinking water quality and requires water utilities to monitor and control lead levels in drinking water. When petitioning for changes to the electrical code, it is important to consider the interplay between these different codes and standards. Any proposed code changes should be consistent with the requirements of the UPC and the SDWA, and they should be designed to minimize the risk of lead contamination in drinking water. It is also important to consult with experts in electrical engineering, plumbing, and water quality to ensure that the proposed code changes are technically sound and effective. These experts can provide valuable insights into the potential impacts of the code changes and can help to identify any unintended consequences. When preparing your petition, be sure to include a clear and concise explanation of the problem, the proposed solution, and the potential benefits of the code change. Provide supporting data and evidence to demonstrate the validity of your concerns and the effectiveness of your proposed solution. Be prepared to address any objections or concerns raised by opposing parties, and be willing to negotiate and compromise to reach a mutually agreeable outcome. Changing electrical codes can be a challenging process, but it is essential for protecting public health and ensuring the safety of our water supplies. By following these steps and engaging in collaborative advocacy, you can increase the likelihood of achieving meaningful and lasting improvements to electrical codes that prevent lead leaching from plumbing systems. Remember, grounding electrode conductors, often abbreviated as GEC, play a crucial role in ensuring the safety and effectiveness of electrical grounding systems. These conductors provide a low impedance path for fault currents to flow back to the source, helping to prevent electrical shock hazards and ensuring that overcurrent protection devices operate properly. The size and material of the GEC are determined by the size of the service entrance conductors and the type of grounding electrode used. The NEC provides detailed tables and guidelines for selecting the appropriate GEC for various applications. Grounding electrode conductors must be properly installed and protected from physical damage. They must be securely connected to the grounding electrode and to the service equipment enclosure. The connections must be made using approved connectors and methods to ensure a reliable electrical connection. In addition to grounding electrode conductors, bonding jumpers are also essential for creating an electrically continuous path between metallic parts of electrical and plumbing systems. Bonding jumpers help to minimize voltage differences and prevent stray currents from flowing through these systems, which can contribute to corrosion and lead leaching. The NEC specifies requirements for the size, material, and installation of bonding jumpers. Bonding jumpers must be sized according to the size of the circuit conductors and must be made of copper or other approved materials. They must be securely connected to the metallic parts being bonded using approved connectors and methods. When addressing the issue of lead leaching from plumbing systems due to electrical grounding, it is important to consider the potential for stray currents to flow through the plumbing system. Stray currents can be caused by a variety of factors, including improper grounding, unbalanced loads, and corrosion of electrical equipment. These currents can accelerate the corrosion of metal water pipes, particularly in older homes with lead pipes or lead solder, leading to the release of lead into the water supply. To mitigate the risk of stray currents, it is important to ensure that electrical systems are properly grounded and bonded and that any potential sources of stray currents are identified and addressed. This may involve conducting electrical inspections, performing ground resistance tests, and installing appropriate bonding jumpers and isolation devices. In some cases, it may be necessary to install a dedicated grounding system for the plumbing system to minimize the flow of stray currents. The design and installation of such a system should be performed by a qualified electrician or electrical engineer. When petitioning for changes to the electrical code to address the issue of lead leaching, it is important to consider the potential impacts of the proposed code changes on other aspects of electrical safety. Any proposed code changes should be carefully evaluated to ensure that they do not compromise the overall safety and reliability of electrical systems. It is also important to consider the costs and benefits of the proposed code changes. The costs of implementing the code changes should be weighed against the potential benefits of reducing lead contamination and protecting public health. The code change process should be transparent and inclusive, with opportunities for all stakeholders to provide input and feedback. This will help to ensure that the final code changes are effective, practical, and widely accepted. Consider seeking support from professional organizations and trade associations that represent electricians, plumbers, and water utilities. These organizations can provide valuable expertise and resources to support your efforts to change the electrical code. They can also help to raise awareness about the issue of lead leaching and to advocate for code changes that protect public health. Remember that changing electrical codes can be a long and complex process, but it is essential for protecting public health and ensuring the safety of our water supplies. By following these steps and engaging in collaborative advocacy, you can increase the likelihood of achieving meaningful and lasting improvements to electrical codes that prevent lead leaching from plumbing systems. Lead service lines, also referred to as LSL, are a significant source of lead in drinking water. These are the small diameter pipes, typically made of lead, that connect the water main in the street to the plumbing inside a building. Homes built before the late 1980s are more likely to have lead service lines. Even if the interior plumbing is copper, the service line itself could still be lead. When water sits stagnant in lead service lines for extended periods, lead can leach into the water. This is especially true if the water is corrosive, meaning it has a low pH or lacks sufficient mineral content to form a protective coating on the inside of the pipe. Partial lead service line replacements can sometimes worsen lead levels in the short term. This is because disturbing the lead pipe can release particles into the water. Additionally, connecting a new copper pipe to an old lead pipe can create a galvanic reaction, accelerating corrosion. For this reason, many experts recommend full lead service line replacements. Water utilities often use corrosion control treatment to reduce lead leaching. This involves adding chemicals to the water that create a protective coating on the inside of the pipes, preventing lead from dissolving into the water. Common corrosion control treatments include adding phosphate or adjusting the pH of the water. Homeowners can take steps to reduce their exposure to lead in drinking water. Flushing the tap for several minutes before using water for drinking or cooking can help to clear out any lead that may have leached into the water. Using a water filter certified to remove lead is another effective way to reduce lead levels. Boiling water does not remove lead. In fact, it can slightly increase the concentration of lead as the water evaporates. Regular water testing is essential to monitor lead levels and ensure that corrosion control treatment is effective. Water utilities are required to conduct regular testing, but homeowners can also have their water tested independently. If lead levels are found to be elevated, it is important to take immediate action to reduce exposure. Public education is crucial to inform residents about the risks of lead in drinking water and the steps they can take to protect themselves. Water utilities should provide clear and accurate information about lead service lines, corrosion control treatment, and water testing. They should also offer guidance on how to reduce lead exposure in the home. Collaboration between water utilities, public health agencies, and community organizations is essential to address the issue of lead in drinking water effectively. By working together, these stakeholders can develop and implement comprehensive strategies to protect public health. Remember, the information provided here is for educational purposes only and should not be considered as professional advice. Always consult with qualified professionals for specific guidance on electrical and plumbing systems.